Okay, so today we're going to talk a little bit about radicals, and it's just going to be, we're not going to fill out this whole thing today. So this whole thing is going to be your notes for today and tomorrow and next week on Monday. Okay, so we're not doing all of this today, but we are going to start on it. So the first thing we're going to talk about when you talk about radicals is we need to talk about our perfect squares and what is a perfect square. Okay, so we're going to go on the side right here and write the perfect squares. So don't write too big because you have a little bit of a lengthy list. So the first one I want to start with is 1. So when you think of a perfect square, it's a number that you can multiply the same number and then you get a number. So for example, let's list the next one, which is 4. So you say, well, how do you get 4? Well, 4 can come from 2 times 2. So that's a perfect square when you can multiply the same number together and then whatever you get is the perfect square. Okay, we can also write that as 2 squared. Okay, so I want you to recognize all 3 of these for 4. Now the reason I have 1 on here is because 1 is a perfect square. We can do 1 times 1 or 1 squared. But a lot of people forget that 1 is a perfect square, so I want to make sure that we write it. Okay, so let's go to our next one. The next one would be 9. 9 comes from 3 times 3, which we'll also write as 3 squared. Then we have 16 is 4 times 4, or 4 squared. So we're going down the list here. 25 comes from 5 times 5, or 5 squared. 36 comes from 6 times 6, or 6 squared. 49 comes from 7 times 7, which is 7 squared. 64 is 8 times 8, which is 8 squared. 81 is 9 times 9, 9 squared. Then we have 100, 10 times 10 is 10 squared. We're going to do 2 more. 121 is 11 times 11, which is 11 squared. And 144 is 12 times 12, so 12 squared. So you want to get used to seeing these numbers here on this list. And the reason is, especially when you get to Algebra 2, you need to be able to recognize, oh, that's a perfect square when you look at this list. So if I say the number like 45, well, 45 is not a perfect square because I can't do the same number and multiply it to get 45. Okay? So on the right-hand side here in this blank space, the other thing I want you to write now is we're going to go the opposite way. So if I was to start with the square root of 1, that would be equal to 1. Okay, so this is, our notes are radical notes. A radical is just this radical sign here, the square root, we're going to call it. Okay, this one we have square root of 4 is equal to 2. So when you take a square root, if I take a square root of this one right here, essentially the square root is eliminating this exponent, which then just results in the number. So then we have square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. We'll just keep on going down. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And the square root of 144 is 12. Okay, so when we're doing radicals, this is more likely what you're going to start with is this radical, and then you're going to get to an answer like this. So that's why I want you to make sure you have this list on your perfect square notes. Okay, so we're done here with the perfect square note part. So I'm going to actually draw a line here on simplify radicals. and you're gonna flip this up, and we're gonna write on the back of that paper. Okay, so let me show you again so you're writing in the correct place. Here's the front of the notes. You're gonna flip open, and I'm gonna write on the back of this part, okay? So at the top, I want you to write, is it a perfect square? Okay, so if our answer is yes, so when you look at something and you say, is it a perfect square? And the answer is yes, you're done. Okay, you don't have to do anything, you don't have to simplify anything like that. Okay, now if the answer is no, then that's where we're gonna go from there. Okay, so that's what this page is gonna be, is how do you simplify a radical? So the first thing we're gonna do, off to the side here, I'm gonna write, make a tree. And let me add factor in there, make a factor tree. Okay, so the example that we're gonna use, let me zoom in a little bit here. The example we're gonna use here is, let's do square root of 72. Okay, so the first thing you ask yourself, is 72 a perfect square? No, it's not on our list, so that's what I'm gonna do here. I'm gonna make a factor tree. So you wanna split 72 up. So when you look at 72, we know it's divisible by 2. So I'm gonna say 2 and 36. Okay, so that's what I would go to, is if it's an even number, go straight to 2. Okay, so then we wanna break down as much as I can. 2 is done, I can't break it down anymore, so I'm gonna just leave it and bring it down. 36 though, I can break up into 3 times 12. Okay, now when you do this, you do not have to do exactly the same numbers as everyone else, because 72 could also be 8 times 9 or 12 times 6. So there's other ways to do your factor tree than what I'm doing here. Okay, so you could have different numbers, but in the end you should have the same answer. So then you look at your 3 numbers. I can't break down 2 anymore. I can't break down 3 anymore. But 12, we could break that down into 4 and 3. Okay, so notice when you say a factor tree, you're getting to the simplest form. Okay, so now I can't break down the 2, I can't break down the 3, but this 4, I can break into 2 and 2. And I can't break down the 3 anymore. Okay, so then I look and see, well, can I simplify any of these numbers again? No, I'm done. They're all simplified. So after that, you want to take out any buddies. So what do I mean by that? Is if you have 2 of something, you can take it out. Okay, so right now, when you look at the square root of 72 and you break it down, all of these are technically still inside of a square root. Okay, but if you have a buddy, you can take it out. So for example, I have 2 2's here. Okay, because I have 2 2's here, I can take out that and it becomes a 2 on the outside of the square root. Okay, so I have a pair of 2's, I can take a 2 out. Then I have a pair of 3's, so I can take a 3 out, and you're gonna multiply it. So this is on the outside of my square root. This 2 is all by itself, so I can't take it out. It has to stay under the square root. So over here under take out buddies, I want you to write maybe like come out of the square root or something like that, because when you have a buddy pair, you can take that out of the square root. Now notice I'm not writing it twice, I'm just writing it once. Okay, so then when you simplify your answer, go ahead and multiply these 2 together. So that would be 6 times the square root of 2. Okay, so this is simplifying using factors. So I'm gonna write that on the side here, just so that you have that. Simplify using factors. Okay, so it will always work like that if that's how you like to do it. When you're making your factor tree, again, you don't have to do it exactly how I did it. You just want to break it down into something that you know. So try and figure out what is 72 divisible by, break it up. Okay, so I want you to go right below this piece of paper. So this is simplifying using factors. Okay, below that, this one right here, I want you to turn the page, and this one is going to be right here on the side. I'm going to write simplify using perfect squares. Okay, so two different methods. Simplify using perfect squares. Okay, so there's going to be two ways you can do it. You can use the factor tree, or you can use perfect squares. Okay, so I'm going to turn it back around. So we're going to use that same example that we just used, square root of 72. So the first thing we want to do, find the largest perfect square that will go into the radicand. And let me tell you what that is. So the radicand, I'm going to underline that because that's a good little vocab word right there. The radicand is just what's under the square root. So 72 is the radicand. So this one says find the largest perfect square that will go into the radicand. So you look at your perfect square list that we made here, and I want to look and see which one of these is the biggest number that goes into 72. Now obviously when I get here, 81 and up will not go in. So then you test these numbers. 72 divided by 64, 72 divided by 49, 72 divided by 36. Okay, so you're looking for the biggest one, which it will be 36. Okay, so let's write here 36. Okay, 36 is the largest perfect square that will go into the radicand. Okay, step 2. Rewrite as a product. So a product meaning rewrite it as multiplication. So we have square root of 72, and we're going to rewrite that as 36, so that was the perfect square we found, times 2. So when you did 72 divided by 36, it gave you 2. So I'm just breaking up 72 into 36 times 2. And now I can split those up. So I can say square root of 36 times the square root of 2. So you're just taking this and splitting it into two radicals. The third step, rewrite the perfect square. Okay, so rewrite the perfect square. So I'm going to rewrite what I have on step 2. Square root of 36 times square root of 2. Now on our perfect square list, the square root of 36 is equal to 6. So if I simplify this square root of 36 to just 6, this one does not simplify, so I just leave it as square root of 2. So we got the same answer here as we got here, just two different methods. So we're going to stop there for today, and we will do more notes on Friday.